Okay, so we left off here on the last video. Notice one thing I want you to pick up on. The structure of creating this new observation within the dictionary is really different. This is a key, and I'm going to introduce this to you more formally in the next slide. This is a key, the citing here, and these keys define what is matched, the value that gets matched to the count, okay? And then we can change and update these counts. All right, so we're using a very particular and distinct syntax here to get this done. A few things to know about dictionaries. The keys are immutable. That means once you create them, they cannot be changed. So you can't go in, for example, if you were forgetting to add in the name of this particular falcon, Harrington falcon, I think it was. You can't go in and change this now. It's just going to read falcon. The values, though, can be mutable. They can be changed, and we did that. We updated the count here. It changed. So here's the structure, though. I really want you to pick up on this. To add a key, so a key is like in our bird example, the name of a bird, and a value, that would be our count, to a dictionary. So notice D is the dictionary, K is the key, and V is the value. Notice how we fit that exactly. Here's our bird dictionary, the key, and the value. If the key is already present, its value will just be overwritten. So for example, if you go out for a bird watching session and you see 20 more ospreys, then you can just update that value to whatever it is. To copy all your key value pairs from some other dictionary, use the update method. I'll let you look that up on your own. It's pretty easy to follow. Use dictionary or dict to shallow copy from another dictionary. That just means basically if, say, you have a dictionary and you need to update it, but you don't want to lose the original version, then you can just make a copy that is say the values are still mutable, can be changed without changing the original value. That's often a very good idea so that you don't lose prior versions. Update and dict also work with a sequence whose elements are all of length 2. I'll talk about that later. I'm not sure we need to get to that. Okay, but let's focus on the stuff that really matters here. Use this syntax here, the dictionary and the key, to obtain your value associated for a particular key within your dictionary. If the key doesn't exist, it's going to give you back an error. So you can go, okay, I want to see what my current count of osprey is. You could plug in osprey for your key, bird dictionary for your dictionary there, and find out what the current count is. You can also use the get method, except it'll return none instead of giving an error when the key doesn't exist, and that might be a little misleading perhaps. If a second parameter v is provided, it returns a v instead when none is found. We haven't talked about that, so don't worry about that right now. Okay, so let's try applying this and see if we can use just our very rudimentary knowledge about this get function, or being able to make use of the get facility in this way. Okay, so first we're making a dictionary. So our dictionary is called D, and it just has like one element, I'd say, in it. 3 is matched with 4 here. Okay, so let's think about here. Our key is 5. Do we have a key that's called 5? Well, no, we don't. Okay, but we can assign it a value where I should have shown you this when the order of the arguments here. is first the key and then the value that should be returned if the key that you're referencing does not exist. Okay, so we're going to create a key 5. Um, the key that we're referencing here is 4, which does not exist in our current dictionary. So it's going to be matched, the value that gets returned instead. I said that wrong. The, the key is 5 and that doesn't exist. So instead of returning the value 4, it'll return the value 8. So notice, let's go ahead and eliminate 2 of these. This is kind of hard to explain, I'm realizing. So I'm going to eliminate 2 of these. Only A and B are possibilities now because our original dictionary contained 3 with 4. With this one, we searched for a key of 5. It didn't exist, so it was created with a matching value of 8. All right. Okay, so let's do the next one. We search for a key of 4. It doesn't exist because right now our dictionary, after we run this line right here, our dictionary is 3 with 4, comma, 5 with 8. So only A and B are going to work here. And we're going to match it with 3, or are we going to match it with 9? It's going to have to be 9 because 4 does not exist. So A here is our correct one. If, say, 5 had existed, then we would have matched it with 4. If 4 had existed, we would have matched it with 3, and then C would exist, would be the right answer. Let's try this again. Here's a new dictionary, 1 with 5. We're going to search for 2. If it exists, we match it with a value of 1. If it doesn't, we match it with a value of 6. Then we search for 4. If it exists, we match it with 3. If not, we match it with 7. So take a moment, evaluate which of these you think is correct. All right, I think I'm going to choose B here. I hope that's right for you as well. All right, so we're going to continue with dictionaries in the next set of slides and learn some more advanced ways to use them because I think they're pretty useful data structures.